Okay, so I'm just going to talk you through IB knowledge of frequency tables, bar charts, and histograms, which are basically basic ways of presenting data. Now, you've seen all of these before, all the way since year 7, so this should be really straightforward for you. But the purpose of making this video was just to explain the difference, I suppose, between IB knowledge and what you're required to know at IGCSE. In many ways, it's actually easier at IB than IGCSE, and also to introduce one sort of concept which might be quite new to you, which is the concept of skew. Okay, so here we've got an example. In the opening problem, you studied the marks of 32 students who took a test with a maximum mark of 10. Well, actually, you didn't, but I'm sure you can imagine that you did. And their scores are listed below. So construct a frequency table for this data and draw a bar chart for it. Okay, so the frequency table, really straightforward. It's what you've been using all the way through high school and possibly beyond, and you literally just count how many are in each category. Okay, so there's one person with a score of 0, and there's 2 people with a score of 1, and 3 people with a score of 2, and so on and so on. Okay, so nothing kind of crazy there. Bar chart, you've also, you're used to seeing bar charts, but the one thing that you may not have sort of realized before is that a bar chart is specifically for discrete data, okay, whereas a histogram is for continuous data. Now, this data, even though it's quantitative, it's numeric, it's discrete, because you can get 0 or 1 or 2 out of 10, but the teacher who marked this doesn't give half marks or anything like that. So you can only have 0 or 1 or 2. You can't have 1.5 or 1.25 or 1.1316. It's discrete data. Okay. Now, because it's discrete data, you're going to have gaps between the bars. Okay. And I'd like you to copy that onto your PDF or into your notes so that you've got a way of remembering it. Okay, so bar chart is for discrete data and you have gaps between the bars. The other thing is a kind of classic mistake if you were asked to draw a bar chart is that people will then do it like this. So for example, we had one person with 0 and we had 2 people with a score of 1. Okay, so people start drawing like this. Well, there's 2 problems here. You've got no gap. Okay, well, that's basically the only problem. So instead, we draw it like this. Okay, so you have the bar in the center of the category. So what I mean by that is also, I guess it's when you draw your scale. When you draw your scale, don't draw a scale that goes like this: 0, 1, 2, 3, with the numbers on the points. Yeah, with your scale, you want the numbers in the middle of the category because that's where you're going to draw your bar. Okay, and that's it really. That's bar charts. And then we're moving on to continuous data. Okay, now although this is also whole numbers, a group of 37 teachers were asked how much time in minutes they spent eating lunch at school. Okay, well, time in minutes is not like marks in a test. Yeah, you can only have discrete values for marks in a test because you can either have 1 or 2 or 3. Possibly you might get half marks. But like, for example, in your IB exam, you only got whole marks. Okay? Whereas time can be measured to any level of accuracy. It just depends how accurate your watch that you're using to measure it is. Okay? So although this is being recorded in, it looks like it could be discrete, it's actually continuous. Okay? So the first thing to notice about continuous data, when you record it, notice how it's written. Yeah, 0. So t is bigger than 0, but is less than or equal to 4. Okay, if you make your categories something like this, then you've got a problem, right? Because if someone has a time of 4 minutes, do they go into this category or do they go into this category? Okay. Likewise, if you do not include if you just have t is less than 4, well, and if it's the same, if it's just a less than sign here, again, if they're 4 minutes, they can't go in either this one or in this one. Okay, so the convention is to basically have your categories using this notation. Definitely not using this. However, just to go back to bar charts and discrete data, it's probably more likely that if you were putting this data into a into a frequency table, that you, instead of having every single score recorded there, you might have a score of 0 to 2, for example. And that's fine if it's discrete data. The only thing you need to be careful of is in your next category, you don't have, for example, 2 to 4. Yeah, and then 4 to 6, and so on, for the same reason as before, because if you have a score of 2, well, where do you put it? Okay, so with discrete data, because you know you can't have a score of 2.5 in this case, then, okay, 3 to 5 is fine, and then 6 to 8, and then like 9 to 10, and it's up to you. You might not have exactly even intervals, but that's fine, so long as the notation is correct like this. All right, but for continuous data, you need to use this notation. Now, so histogram is for, before I go on to that, let's just reveal these frequencies. So it's just, in this example, it's just exactly the same. It's just counting and putting the frequencies into the table. Okay. Now, the other note that I'd like you to make is that histograms are for continuous data. Okay, and that means that the bars are touching, okay, to sort of represent the fact that the data is continuous and there's no gaps between it. However, the good news for you is that at IB, the histograms will always have even data widths. Even class intervals. Okay, and what I mean by that is that all these intervals have a width of 4, 4 hours. Okay, whereas at IGCSE you had, for example, you might have had something that looked like this. Okay, and you'll remember at IGCSE that the frequency wasn't given by the height of the bar, but by the area of the bar. And therefore, we had to change this from frequency to frequency density. Okay? And then you multiply the frequency density by the width to get the area and therefore the frequency. Well, good news for you is that at IB you don't need to worry about frequency density because you've always got even class intervals. The frequency or the y-axis is just the frequency. Okay, so the only real difference between a histogram and a bar chart at IB standard level is that one is for continuous data and has the bars touching, and one is for discrete data and has gaps between the bars. If you wanted to do something with histograms for your IA and you wanted to have differing class intervals, then obviously make sure you change it back to frequency density, revise the work you did at IGCSE, and actually that would get you some points in your criteria E, the use of mathematics, because it would be slightly beyond IB standard level. Okay. Now, the other thing that will be new to you is this idea of describing skew. Okay, so you might have done some of this in Key Stage 3, but you probably didn't do it at IGCSE in the last 2 years, in years 10 and 11. Okay, now slightly, so skew just describes whether the data is bunched to the left or to the right. Yeah, so whether the data is bunched towards the lower numbers or is bunched towards the higher numbers. Now this one is like a normal distribution. So if I sort of plotted it like this, where I just took the central point of each bar and plotted it and joined it with a line, you'd have what's called a normal distribution. This is something we're going to look at in a bit more detail later on. This one, if you sort of drew a frequency polygon or something, you drew a line, you can see that the tail stretches towards the left. Okay, so although the data is bunched on the right hand side, we actually call this left skewed, okay, because the tail stretches to the left, or negatively skewed. And this is the language I want you to use: negatively skewed or positively skewed. Again, it can be quite counterintuitive that you might think, okay, well here the data is bunched towards the left, so it's left skewed, but it's not. It's all to do with thinking about the tail, okay? So the tail, this sort of region here, this is skewed towards the right. So we say it's positively skewed or right skewed. Okay, basically, I'd like to do exercise 6B, questions 1, 3, and 4.